Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Our today topic is for exercise 2.2 symmetric functions. So, symmetric function mean alpha plus beta, alpha into beta, alpha square plus beta square, etc. By symmetric function we mean if we interchange the value of the given quadratic equation. So the value of the roots of the quadratic equation remains the same. The value of the quadratic equation remains the same. That is why we call it symmetric function. For example, come to example 16, part first. If alpha beta are the roots of this standard form of quadratic equation, then find value of symmetric function. So here alpha plus beta is symmetric function. So as alpha beta are the roots of the given quadratic equation, so we have already proved this result. Sum of the root is equal to minus b by a. Similarly, the same example 16 part 2. If alpha beta are the roots of this quadratic equation, find the value of symmetric function alpha beta. Alpha beta mean product. So we have already proved this result. Therefore, as alpha beta are the roots of the given quadratic equation, so product of the root is equal to c by a. Similarly, another functions alpha square plus beta square. If we find the value of or interchange alpha square plus beta square into sum and product, because sum of the root and product of the root, these are two basic results, basic symmetric functions. So every type of symmetric function we will change this into sum and product, like this one, example part 3. Then find the value of the symmetric function alpha square beta square. So for alpha square beta square we can write this and transform this into the form sum and product, because we have basic value two results, sum and product. So how we can transform this into sum and product? By adding 2 alpha beta plus 2 alpha beta to alpha square plus beta square, it becomes a complete square. So by adding 2 alpha beta, we subtract 2 alpha beta, because the same term we cancel again. We get from the first three term alpha plus beta whole square minus 2 alpha beta. By putting the values, this symmetric function change to sum and product form. So that is the basic question. Every symmetric function can be changed into symmetric into sum and product of the root. Then by putting the values, we get the value of the given symmetric function. So by putting the value of sum of the root minus b by a square minus 2 and product of the root c by a. Simplifying this one, that become b square by a square minus 2c by a. So multiply and divide this by a to get a square. This one to get the same LCM. Now a square is the LCM. We get b square minus that become 2ac. So that is the value of symmetric function alpha square plus beta square. Similarly, part 4, example 16, another symmetric function alpha cube beta cube. How we can find the value? We will find the value of this symmetric function by changing them into sum and product of the roots of the given quadratic equation. So as alpha beta are the roots of this quadratic equation, so expanding again, sum of the root will be minus b by a and product of the root is equal to c by a. So finding the value of this symmetric function alpha cube plus beta cube. We have a formula alpha plus beta whole cube is equal to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. Using this result, we can change this into the form. First alpha plus beta whole cube. That become these three terms. Alpha plus beta minus 3 alpha beta into alpha plus beta. They again minus plus cancel, we get alpha cube plus beta cube, which is the required function. So we can thus alpha cube plus beta cube is changed into sum and product of the roots of the given quadratic equation. So putting the values of sum and product in this relation, sum of the root minus b by a cube minus 3 into product of the root c by a into sum of the root minus b by a. Simplifying, that become minus b cube divided by a cube, and minus minus become positive, plus 3bc divided by a become a square. Now multiply and divide by a to get a cube, the same LCM. So again, taking a cube as LCM, we get minus b cube plus 3abc divided by a cube. So that is the value of symmetric function alpha cube beta cube. Thus, by symmetric function we mean if we interchange the roots from alpha beta to alpha square beta square alpha cube beta cube, etc., the value of the quadratic equation or the roots of the quadratic equation remains the same. Now come to exercise 2.4. Question 1, the same symmetric function. If alpha beta be the roots of the given quadratic equation, find the value of alpha cube beta plus beta cube alpha. So already the known result are sum of the root of standard form of quadratic equation, that is minus b by a, and their product is equal to c by a. Now changing this to find the value of symmetric function alpha cube beta plus beta cube alpha, we change this symmetric function into sum and product by, first of all, look at this expression. Alpha beta is common, so by taking alpha beta common we get alpha square plus beta square. Now change this alpha square plus beta square again into sum and product. So alpha beta into, by adding 2 alpha beta and subtracting 2 alpha beta, from the first three terms we get alpha plus beta whole square minus 2 alpha beta. This change into product, sum and product. Now by putting the values of sum of the root and product of the root in the given expression, alpha beta is c by a into alpha beta square, alpha plus beta square minus b by a square minus 2 into alpha beta value is c by a. Simplifying this expression, c by a into that become b square by a square minus 2c by a. Again this term multiply and divide by a to get a square, the same LCM. So a square is the LCM, we get b square minus 2ac, and c is totally common, r a multiply a square with a, we get c into b square minus 2ac divided by a cube, which is the value of alpha cube beta plus beta cube alpha, symmetric function. Similarly, part 2, if alpha beta be the roots of quadratic equation ax square plus bx plus c equal to 0, find the value of alpha minus beta whole square, symmetric function. So again we know the value of sum of the root, product of the root. According to the given condition, we use formula to find the value of alpha minus beta whole square. We have a formula, alpha plus beta square whole square minus alpha minus beta whole square is equal to 4 alpha beta. Basic formula number 3, which is already proved. So we can form this, write this in the form, because we are going to find the value of alpha minus beta square. So from that result we write this as alpha minus beta whole square is equal to alpha plus beta square minus 4 alpha beta, or by expanding both the side we get the same value. So we can check this, we can verify this result. Now by putting the values of sum of the root, product of the root in the given expression, and on the left hand side alpha minus beta we have to find. So putting the values of the sum and product, That become on the right side sum of the root minus b by a square minus 4 product of the root c by a. Expanding, that become b square minus or a square minus 4c by a. Again multiply divide by a. That become a square is the LCM, we get b square minus 4ac. And on the left side alpha minus beta square. So that is the value of, which is the required value of alpha minus beta whole square. Now come to another next topic, formation of quadratic equation through roots. So in the beginning of this chapter we were finding the roots of the given quadratic equation. Now the roots are given, we have to form a quadratic equation. So for formation of a quadratic equation we have this form. We prove a relation which is the formation of the quadratic equation through roots. So if the roots are given, we use this formula. Write standard form of quadratic equation. Again dividing the whole equation by a, coefficient of x square. It become x square plus b by a x plus c by a. Or we can write this x square minus b by a. This one minus minus again become positive b by a. Because sum of the root is minus b by a, we change this into the form sum of the root into x plus c by a, already product of the root. Or we can write this is x square minus b by a means sum of the root alpha plus beta into x plus c by a means product of the root alpha beta. Or sum of the root denoted by s, product of the root denoted by p. So in short we can write the formula for formation of a quadratic equation is x square minus sx plus p is equal to 0, where s is the sum of the root and p is the product of the root. So for formation, to form a quadratic equation when its roots are given, we have to find two things, sum of the root, product of the root, and put them in the given relation. Thus we will get the required equation. For example, now come to question 2. Find quadratic equation whose roots are 1 and 1 by 2. Now the roots are given, we have to form quadratic equation. So for formation of quadratic equation, first two things, sum of the roots. Roots are given 1 and 1 over 2, so their sum 1 plus 1 by 2. 2 is the LCM, 2 plus 1 are 3 by 2. Sum of the root we get 3 by 2, sum of these two roots. Similarly, product of the root 1 into 1 by 2 is equal to 1 by 2. So we get two results, sum of the root, product of the root. Now the required equation is x square minus sum of the root into x plus product of the root is equal to 0. Putting the values are x square minus 3 by 2, sum of the root plus product of the root 1 by 2 is equal to 0. So 2 to cancel 2 multiply both sides by 2. We get 2x square minus 2 cancel minus 3x, or here 2 cancel plus 1. So 2x square minus 3x plus 1 is equal to 0 is the required equation. Now we can check our result by solving this quadratic equation. If we solve this quadratic equation, we get again the roots 1 and 1 by 2. So in this, for formation of quadratic equation, mean the roots are given, we have to find the quadratic equation. In the beginning, quadratic equation were given and we were solving them. Now come to question 2. Part 3. Find quadratic equation whose roots are. Two roots are given, three irrational roots. So first of all we find the sum of the root alpha plus beta. That is 3 plus under root 2 plus 3 minus under root 2. So plus under root 2 minus under root 2 cancel each other. 3 plus 3 we get 6. Product of the root alpha beta, 3 plus under root 2 into 3 minus under root 2. So we have the form a plus b into a minus b is equal to a square minus b square. Using that formula, we have 3 square minus under root 2 square in a square minus b square form. Expanding this 3 square 9 under root 2 square cancel with square root cancel with square only minus 2. So 9 minus 2 7. Thus two results alpha sum of the root product of the root are known by putting the sum and product in the relation. The required equation is x square minus sum of the root into x plus product of the root is equal to 0, or simply x square minus sx plus p is equal to 0. So x square minus sum of the root, that is 6x plus product of the root plus 7 is equal to 0, which is the required equation. Next, question 3. Form a quadratic equation whose roots are square of the roots of this equation. So generally we take alpha beta are the roots of, since alpha beta are the roots of this quadratic equation, so sum of the root minus b by a product of the root c by a, that is general form. Now required equation, we have to find an equation whose roots are square of the roots of this. Square of the root mean the roots of the required equation will be alpha square beta square. So again sum of the root alpha square plus beta square, change this into sum and product form by adding 2 alpha beta and subtracting 2 alpha beta. From the first three we get alpha plus beta whole square minus 2 alpha beta, putting the value of sum and product. So minus b by a square minus 2 product of the root c by a. Simplifying that, we get b square by a square minus 2c by a. Multiply and divide by a to get a square, the same LCM. So a square is the LCM, that is b square minus 2ac. So that is sum of the root, now product of the root. Alpha square beta square. We can write this alpha beta whole square. Now putting the values, product of the root alpha beta is c by a square, or we get c square by a square. Putting these values, the required equation is given by x square minus sum of the root into x plus product of the root is equal to 0. So x square minus sum of the root is b square, this one, b square minus 2ac by a square, into x plus product of the root is c square by a square is equal to 0. Now again a square is in the quotient. So multiply both sides by a square. We get x square, multiply both sides by a square. So we get a square x square minus a square cancel with this one. We get minus b square minus 2ac into x plus a square cancel with a square plus c square is equal to 0, which is the required quadratic equation. Now come to 4. If alpha beta be roots of the given quadratic equation, 2x square plus 3x plus 1 equal to 0, then find the value of alpha by beta plus beta by alpha, symmetric function. So first of all we take this quadratic equation. Comparing this with the standard form of quadratic equation, we get a is equal to 2, b is equal to 3 and c is equal to 1. Since alpha beta are the roots of this quadratic equation, so sum of the root minus b by a become minus 3 by 2, and product of the root c by a means c is 1, a is to 1 by 2. Now value of symmetric function alpha by beta plus beta by alpha. So we can write this is alpha by alpha, multiply and divide by alpha, multiply by alpha by beta, plus multiply second term by beta to get the same LCM. Now if we look alpha beta mean LCM is alpha beta. By taking LCM alpha beta we get alpha square plus beta square. Now change this alpha square beta square into sum and product form. By changing them into, we can write this alpha square plus beta square plus 2 alpha beta minus 2 alpha beta, or alpha plus beta whole square minus 2 alpha beta divided by alpha beta. Now putting the value of sum and product in the given relation. By putting the values, we get sum of the root, that is minus 3 by 2 square, minus 2 into product of the root 1 by 2, divide by alpha beta. Alpha beta product of the root divided by 1 by 2. Now simplifying this one, minus 3 by 2 square become 9 by 4. Minus that again we multiply and divide by 2 to get the same LCM. That is 2 by 2 multiply by 2 by 2. So we get 4 by 4. And division will change into multiplication. Multiply by that takes the form reciprocal. Multiply by 2 over 1 by changing division into multiplication. So that become 9 by 4, or take the LCM. 4 is the LCM. We get 9 minus 2 to the 4. Multiply by 2 over 1. 9 minus 4, 5. And 2 cancel with 2. 2 to the 4. So 5 by 2. Thus alpha over beta plus beta over alpha is equal to 5 by 2. That's the value of the required symmetric function. Now part 3 of question 4. If alpha beta be the roots of this quadratic equation, 2x square plus 3x plus 1 equal to 0, then find the value of this symmetric function. Again the same repetition. First of all we compare this with the quadratic equation and get the value of a, 2, b, 3, c1. Thus first of all find sum of the root and product of the root. Now we change this relation. Alpha square by beta plus beta square by alpha is equal to, first multiply and divide by alpha to get alpha beta. Alpha by alpha, and with second we multiply beta by beta. Look at these two terms, alpha beta. So that is common, that become the LCM. So by taking alpha beta as the LCM, we get alpha cube plus beta cube. Now change alpha cube plus beta cube into sum and product form. We can write this as in the form as earlier we have proved. Alpha cube plus beta cube, that is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So this expression is changed to sum and product form. Now I'm putting the values of sum and product. That is equal to sum of the root alpha plus beta, that is minus 3 by 2. So minus 3 by 2 cube minus 3 into alpha beta 1 by 2 into again sum of the root minus 3 by 2, and the whole divided by alpha beta mean product, whole divided by 1 by 2. Simplifying this one, minus 3 cube minus 27, 2 cube by 8 plus that become minus become positive plus 9 by 4. So 9 by 4 again multiply and divide by 2. We get the same LCM. 8 is the LCM. So we get minus 27 plus 9 to the 18. And multiply by division change into multiplication. 1 over 2 become 2 over 1. Multiply by 2 by 1. Again 2 cancel with 8. 2 4 is 8. And minus 27 plus 18 minus 9, and from this side we get 4. So the value of the symmetric function is minus 9 by 4. Now come to 5. If alpha beta be the roots of the given quadratic equation 3x square minus 2x plus 5 equal to 0, then find the equation whose roots are. We have to find the equation whose roots are these two, alpha over beta, beta over alpha. So first of all compare this given quadratic equation with the standard form. We get a 3, b minus 2, c 5. Since alpha beta are the roots of the given, so sum of their root 2 by 3, product of the root 5 by 3. These roots of the required equation are. Now required equation, if these are the roots, alpha over beta, beta over alpha. So first of all their sum, alpha over beta plus beta over alpha is equal to, now by taking LCM alpha beta directly, or multiply the first with alpha alpha and second with beta by beta. So this become alpha beta LCM alpha square plus beta square. Now change alpha square plus beta square into sum and product form. we can write this as in the form alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. From the first three, we get alpha plus beta whole square minus 2 alpha beta divided by alpha beta. Now putting the values of sum and product in the given relation, we have 2 by 3 square means sum of the root. Sum of the root is 2 by 3. So 2 by 3 square minus 2 into product of the root. Product of the root is 5 by 3. Divide by alpha beta. So divide by alpha beta product is 5 by 3. Simplifying this relation. So here that become 2 by 3 square mean 4 by 9 minus that become 10 by 3 and multiply by that we take the reciprocal, change division into multiplication, multiply by 3 by 5. Again 9 is the LCM. If 9 is the LCM, we get 4 minus 30 or beta plus alpha plus alpha by beta plus beta by alpha is equal to 4 minus, again this 3 cancel with 9, 3 3s are 9 and 3 5s are 15. So 4 minus 30 become minus 26 and 3 into 5 15. So thus the sum of the roots is equal to this one. Now their product of the root alpha by beta into beta by alpha, they will cancel each other, is equal to 1. So we get two values, sum and product of the required equation. So putting in the given relation, x square minus sum of the root into x plus product of the root is equal to 0. X square minus sum of the root is minus 26 by 15 into x plus product of the root is 1 is equal to 0. So this we get minus minus again positive and multiply both sides by 15. So we get 15x square minus minus positive plus 26x plus 15 equal to 0, which is the required equation with the roots, with the given roots alpha by beta and beta by alpha. Next, the last question is 6. If alpha beta be the roots of quadratic equation, this one, then find equation whose roots are only the symmetric function is changed, only the roots we have to find. The remaining method is the same. So first of all, comparing the given equation with the standard form quadratic equation to find the value of a, b and c. Thus sum of the root minus b by a, putting the value sum of the root we have 4, product of the root 2. The roots of the required equation are, now new roots are alpha plus 1 over alpha, beta plus 1 over beta. These are two new roots. So sum of the root become alpha plus 1 over alpha plus beta plus 1 over beta. So we write first alpha plus beta first plus next two term, these 1 over alpha 1 over beta. So we can write this in the form, or simply direct we can take 1 over alpha plus 1 over beta. Alpha beta is the LCM. So by taking alpha beta is the LCM, we get alpha plus beta, yeah, beta plus alpha. So we get two symmetric function. Alpha plus beta, we have the value. Beta plus alpha, we have the value. Alpha beta product form. So putting the values. Now on the right side we have sum of the root, that is 4, plus beta, sum of the root alpha plus beta 4, divide by product of the root, that is 2. So simplify this one, 4 plus 2 by 2 cancel, 2 to the 4, 4 plus 2 6. The sum of the root becomes 6. Now product of the roots of the new roots, alpha plus 1 over alpha, beta plus 1 over beta. So if we multiply first alpha with this one, that become alpha beta plus again alpha multiply with this one. So we get alpha by beta, this one, plus is multiply this one with the next, that become beta by alpha, plus multiply this with the last one. So that become 1 over alpha beta. Now we multiply here alpha by alpha, this term alpha by beta with alpha by alpha. to get the same LCM. Similarly, beta by alpha multiply and divide by beta by beta. So we look at the term alpha beta, that is common. So take the LCM in alpha beta, the last term plus 1 over alpha beta plus next LCM of these two terms. That alpha beta, so we get alpha square plus beta square. Again we change alpha square plus beta square into sum and product form. So we can write this as alpha beta plus 1 over alpha beta plus, in this form, alpha plus beta whole square minus 2 alpha beta divided by alpha beta. By putting the values of the sum and product in the given relation, we have product of the root 2 plus 1 over product of the root 2 plus sum of the root 4 square minus 2 into product of the root 2 divided by 2. Simplifying this one. So multiply and divide this 2 by 2. So that become 4 by 2. And next plus 1 by 2 plus next relation 16 minus 2 to the 4. That is 12 by 2. So by taking 2 LCM we can write 4 plus 1 and this one 16 minus 4 12, or we can write simply 16 minus 4, both the term are directly, we can write 12 is equal to, so 4 plus 1 5 16 21 minus 4 17 by 2, that is product of the root. So by putting sum and product of the root, value of the sum and product, the required equation becomes x square minus sum of the root into x plus product of the root is equal to 0. That is x square minus 6 into x plus product of the root 17 by 2 is equal to 0. Now multiply both sides by 2 to remove this 2. So multiply and divide by multiply both sides by 2, we get 2x square minus 12x plus 2 to cancel, 17 is equal to 0, which is the required equation. So that is the end of our today lesson. Thank you so much. See you next with the new topic. Allah Hafiz.